3 engines, a silhouette no airliner had worn before and few would wear again. For a few years in the 1970s, one word was enough to make people nervous about flying: DC-10. It wasn't the deadliest plane ever built. It wasn't even by the numbers an especially dangerous one. But somehow, in the space of about 7 years, the DC-10 became the aircraft the flying public trusted least, a reputation that has outlived almost everyone who built it, flew it, or was afraid of it. So what actually happened? Was the DC-10 a flying disaster waiting to happen, or a solid aircraft that got unlucky at exactly the wrong moment, in exactly the wrong decade, in front of exactly the wrong headlines? Let's find out. To understand why the DC-10 became controversial, you first have to understand that it was never supposed to be controversial at all. It was supposed to be an answer. In 1966, American Airlines came to the manufacturers of the world with a very specific problem. They wanted a wide-body jet, something in the same class as the brand-new Boeing 747, but smaller and capable of operating out of runways that couldn't handle a 747's enormous length and weight. They needed to fly big, comfortable, long-range routes without needing 1.5 miles of concrete to do it. Douglas Aircraft had already been circling this kind of design, having pitched a heavy-lift transport to the Air Force that didn't go anywhere. Then, in 1967, Douglas merged with McDonnell Aircraft, and the combined company, now McDonnell Douglas, inherited the project as its first real shot at a commercial airliner. The early sketches looked nothing like what eventually flew. One proposal was a 4-engine double-decker aircraft that could carry more than 500 passengers, roughly as long as the existing DC-8. Engineers eventually shelved that in favor of something leaner, a single-deck aircraft with 3 engines, seating a maximum of around 400 people. Here's the detail people forget. American Airlines had asked for a twin-engine jet, 2 engines, not 3. So why did McDonnell Douglas hand them a trijet instead? 2 reasons. First, when the company surveyed the airlines who'd actually be buying this thing, a 3-engine layout came out ahead. Second, and this mattered a lot, airlines were worried about engine failure performance at high-altitude, hot-weather airports, places like Denver's old Stapleton Airport, where a jet climbing out on one dead engine needed all the extra push it could get. A 3rd engine mounted in the tail gave that extra margin. And there was competitive pressure baked in from day one. Lockheed was racing to build almost the exact same kind of aircraft, the L-1011 TriStar, for the exact same customers. Whoever got to market first with the better price was going to win this fight. In February 1968, American Airlines and United Airlines placed the launch orders, 25 aircraft for American, 30 for United, and the sales war between 2 nearly identical trijets began before either one had so much as left the ground. The DC-10 ultimately won that war. Not because it was a dramatically better aircraft, but because Lockheed's TriStar showed up late and cost more. Simple as that. The finished DC-10 came in a few flavors. The Series 10 was built for shorter domestic transcontinental hops, running General Electric engines. The Series 30 and Series 40 were built for true intercontinental range, with a 3rd main landing gear leg bolted on to handle the extra fuel and weight. The Series 30 kept the GE engines, while the Series 40 switched to Pratt & Wet power. Later, the U.S. Air Force would take the Series 30 airframe and turn it into the KC-10 Extender, an aerial refueling tanker that stayed in military service for decades. None of this is the story of a corner-cutting aircraft. It's the story of an aircraft built to solve a real operational headache, competing hard against a rival with almost the same specs, racing to be first. Everything that happens next has to be understood against that backdrop, because the flaws that would nearly sink the DC-10's reputation weren't the result of a lazy design. They came from one very specific, very stubborn engineering decision that nobody wanted to revisit. The DC-10's cargo doors opened outward. That was deliberate. An outward swinging door doesn't eat into usable cargo space the way an inward opening one does, so the hold could be packed completely full. But there's a catch. A door that opens outward has to fight the cabin's internal pressure at altitude, which is constantly trying to push it open. That means the locking mechanism has to be strong, precise, and absolutely certain, because if that door lets go at 20,000 feet, the sudden decompression doesn't just cause a bad day. It can rip apart the floor structure above it, and that floor is where the control cables for the tail run. McDonnell Douglas knew there was a problem before the DC-10 ever carried a paying passenger. During a 1970 ground pressure test, one of the cargo doors blew open, and the resulting decompression collapsed part of the cabin floor exactly like engineers feared it would. That should have been the end of the story right there. A flaw caught early, fixed early, forgotten. It wasn't fixed. The dispute over how to properly redesign the locking system dragged on between McDonnell Douglas and Convair, the subcontractor that had actually engineered much of the fuselage. And here's the part that makes this whole chapter so uncomfortable in hindsight. Convair's own engineers reportedly flagged serious concerns about the door, but Convair's contract with McDonnell Douglas barred it from raising those safety concerns directly with the FAA. The company that saw the danger most completely wasn't allowed to sound the alarm. The FAA certified the DC-10 anyway in July 1971 after an enormous flight test program, close to 930 flights and over 1,500 hours in the air. That's not a company skipping steps, that's a company running the process by the book on an aircraft with one specific defect that hadn't been properly solved. Less than a year into commercial service, the defect found its moment. On June 12, 1972, American Airlines Flight 96 climbed out of Detroit with an aft cargo door that looked, checked, and felt secure. It wasn't. At roughly 11,750 feet, the door blew off the aircraft. The decompression collapsed the cabin floor and sliced through several of the control cables running back to the tail, the same vulnerability engineers had glimpsed 2 years earlier on the ground. The aircraft was left flying an aircraft that barely responded to their inputs. And they landed it, safely. Every single person aboard survived. Investigators from the NTSB dug into exactly how this had happened, and what they found should have grounded the design on the spot. The door could be physically closed and appear locked, visually and on the cockpit indicator, without the locking mechanism actually being fully engaged. There was no reliable way for a ground crew member or a pilot to know the door wasn't truly secure until it was too late. So what happened next? Not a mandatory fix, not a redesigned order to cross the fleet. Instead, the head of the FAA at the time, John Schaffer, and McDonnell Douglas's president, Jackson McGowan, worked out an informal, voluntary agreement to address the issue. No binding directive, no enforced timeline. The underlying design stayed exactly as it was, and DC-10s kept flying with the same latent flaw, while smaller door-related incidents kept quietly occurring around the world. 2 years after Flight 96 survived, the same failure happened again, except this time there would be no lucky landing. On March 3, 1974, Turkish Airlines Flight 981 took off from Paris carrying 346 people. Minutes into the flight, the aft cargo door failed in almost the exact same way it had over Windsor, Ontario 2 years earlier. The decompression collapsed the cabin floor and severed the flight control cables running back to the tail, the same vulnerability engineers had glimpsed 2 years earlier on the ground. There was no recovery. All 346 people aboard were killed. To this day, it remains the deadliest single aircraft accident in history without a single survivor. This is the moment. If you're looking for the exact instant the DC-10's public reputation was written in permanent ink, it's this one, less than 3 years into the aircraft's commercial life. The fallout was swift, and for once, decisive. A subcommittee of the U.S. House of Representatives launched an investigation, not just into the door mechanism itself, but into how the FAA had ever certified it in the first place, and why an informal handshake agreement had been allowed to substitute for a binding safety fix after Flight 96. That investigation led to a real, mandatory airworthiness directive. Every DC-10 in service was modified to correct the door design once and for all. And here's the detail that almost never makes it into the popular version of this story. After those modifications, the DC-10 never experienced another cargo door failure, not one. The fix worked. The flaw that killed 346 people over France was the same flaw that had nearly killed everyone on Flight 96, and once regulators forced the issue instead of negotiating around it, it disappeared from the aircraft's history entirely. But reputations don't read engineering reports. By 1974, DC-10 and disaster were fused together in the public mind, and nothing that happened afterward, including years of the mechanical problems simply not existing anymore, was going to easily pry them apart. If the Paris crash set the DC-10's reputation, the next disaster cemented it as something close to unshakable. On May 25, 1979, American Airlines Flight 911 lifted off from Chicago O'Hare. Seconds into the takeoff roll, the left engine, along with the pylon holding it to the wing, tore completely free of the aircraft. As it separated, it severed hydraulic lines that controlled the leading edge slats on that wing. Without hydraulic pressure holding them in place, the slats retracted on their own under the force of the airflow. The left wing, no longer generating the lift it needed, stalled. Combined with the asymmetric thrust from the now missing engine, the aircraft rolled hard to the left and went down just seconds after leaving the runway. 271 people aboard were killed. 2 more died on the ground. It remains to this day the deadliest aviation accident in United States history. The FAA's response was immediate and total. On June 6, 1979, it withdrew the DC-10's type certificate outright, not just grounding the American fleet, but banning the aircraft from U.S. airspace entirely. For 5 weeks, the plane that had already survived one national scandal was effectively erased or remarked in skies. Here is where the story gets complicated in a way that rarely survives the retelling. The investigation that followed didn't find a design flaw in the engine mount itself. It found something else entirely. American Airlines had been using an unauthorized maintenance shortcut, removing the engine and its pylon as a single combined unit during heavy maintenance, instead of detaching them separately, exactly as McDonnell Douglas's own procedure specified. That shortcut placed enormous stress on the pylon's mounting structure, stress the design was never meant to absorb, and it eventually cracked. That November, the FAA fined American Airlines for the maintenance failure. Once the FAA had the slat-installed warning systems modified to reduce the consequences of a similar failure in the future, the grounding was lifted on July 13, 1979, and the DC-10 returned to service. But think about what the public actually absorbed from that summer. They didn't absorb one airline used a maintenance shortcut against the manufacturer's instructions. They absorbed the DC-10 fell apart on takeoff and the government grounded the entire fleet. The distinction between a design failure and an operator's maintenance failure is enormous from an engineering standpoint. It's the difference between an unsafe aircraft and a safe aircraft that was mishandled once by one carrier. But it's a distinction that doesn't fit into a headline, and it never really caught up with the story that had already taken hold. By 1980, new orders for the DC-10 had essentially dried up. In August 1983, McDonnell Douglas announced it would end production, citing weak sales and the aircraft's aging fuel economy as much as its reputation. A trickle of orders kept the line running a little longer, and the very last DC-10, the 446th ever built, counting military and Kinfers, rolled off the line in 1989, delivered to Nigeria Airways. You might expect the story to end there. It doesn't, not quite. On July 19, 1989, United Airlines Flight 232 was cruising with a full load of passengers when its tail-mounted engine suffered an uncontained failure, meaning fragments of the failing engine sprayed outward with enough force to cause real structural damage nearby. That mattered enormously on the DC-10 because all three of its independent hydraulic systems ran close together, right beneath that tail engine. In theory, three separate hydraulic systems should mean redundancy. If one fails, the other two keep the aircraft controllable. The DC-10 designers had judged the odds of losing all three simultaneously to be so remote that they built no backup, no manual reversion for that specific scenario. The uncontained failure ruptured all three hydraulic systems at once. The flight crew was left with an aircraft that had, for all practical purposes, no conventional flight controls at all. What happened next is one of the most remarkable pieces of airmanship in aviation history. The crew, helped by an off-duty DC-10 training instructor who happened to be riding as a passenger that day, worked out how to steer the aircraft using nothing